Okay, all right. So what we're gonna do today is this. We are going to spend one day on systems of equations. Now, can you think of what systems what are the systems of two equations that we can possibly do given where we are in the year and in the unit? I mean, what are the two types of functions do you think we're gonna use? Right? One is gonna have to be a parabola. We've been only spending about the last 2 months on a parabola, right? And what do you think the other one would be? Yeah, it could be a parabola, but we're not going to put two parabolas together, okay? Yeah, linear equation. So we're going to put a straight line together with a curve, all right? And then see what the solutions are. So it's really straightforward, okay? But, so I'll try to keep it short because, this is, again, it's just a mixture and an amalgamation of topics of everything that we've actually done before, okay? And quite easy too, okay? So let's take a look. All right, so write this down, okay, if you want to. All right. We're talking today with systems of equations with quadratics, okay? So we're talking about linear quadratic solutions. Now, as always, we always look at the graphical form of that first. So meaning like, take a look at this. Right? What if we had a linear function, right? Let me write it out, okay? Right, so what if we have a linear function here, right? Straight line, meaning, remember this, y equals to mx plus b, right? If we had this, or like the standard form, right? Ax plus y equals c. First, combined with a quadratic function. All right, so we're looking at, your very basic, like x squared, ax squared plus bx plus c, right? So on and so forth, right? So that's what we're looking at. Now, have you noticed, right, in an ideal world, all right, in an ideal world, you would have two solutions, right here and right there, right? Now, of course, doesn't happen all the time. So, for example, let me draw a very thin red line to show you what can happen, right? Wow, that's a little too thin, actually. All right, okay. Right? So you can have one solution. Let me lock this guy in. Hold on 1 second. So it doesn't move. All right, let's see. Lock in place. All right. Okay. So let's say we got this line, right? It could touch at one place like this. It can happen, certainly. All right? I've seen that before. Or it can have no solution. They don't intersect at all. Like it'll just look like that. All right? Like they'll never cross one another. Okay, so those are the possibilities, right? Now, that said, actually, if we want to save time, I think you should just graph one of these. Now, I'm showing you Regents questions, okay? But the questions just simply are not difficult enough for us to have to spend any more time than is absolutely necessary. So what I want you to do right now is to graph this one on a piece of graph paper, and this is the only graph I'm going to have you do, okay? And I'm going to show you two more questions, and then I'm probably going to stop. So today's video is going to be kind of short. So I need you to follow what I'm trying to get you to do here, all right? Which is on a piece of graph paper, take a moment, press pause, all right? Set up an x and y axis, graph this on the graphing calculator, look at the table values, plot the points, and then determine what the solution is, or the solutions, okay, or no solution, all right, to this set, all right. Now, actually, you can just do that right now if you put that in the graphing calculator, right? Both equations at the same time. So what I'm gonna do then is give you a moment, all right. Now, in a perfect world, I would remember that I made this video and that when I edit it, I can just simply fast forward the graph. So if I remember that, that's great. If I don't remember that, then it's gonna be a little bit slower. Okay, so press pause right now. When you come back, I'm just gonna plot the points actually. Okay, all right, so press pause right now. All right, now I just plotted the two lines, so I'm going to label it. All right, so let's say, what is this? This is the y equals x minus 1. This is the y equals to x squared plus 4x minus 5. All right, now I know what my two solutions are. I'll use my highlighter right here. it's not dark enough. And right here, let me use pink. Right here, and right here. All right. Now, on the calculator, you can see it. So if you just want to be like double sure, you can just go look at the table value, see where. So now again, where to look, right? Wherever the two values are the same, right? You see here how they're both the blue and the red, right? Both the quadratic in blue and the linear in red are both negative. So you know that's one of the solutions. So the first solution is -4, -5. So let's say, right, so we got solution is -4, -5. Now what's the other solution? Because there's this point. Now it's 1, 0, I know. And I look down here, right? Double 0, right? So 1, 0. And that's it. All right, what else? What else do I have to tell them? Self-following, graphically state a corner. Yeah, that's it, okay? So with any one of these, like if you really want more practice, all right, you can try this one. I got a couple more actually. You can try one of these, all right? These are all like, I mean, this is if you're gonna see this on the regions, this is as difficult as it's gonna get. Now, for something like this, let me just point out to in your direction, right? You gotta make sure it's y equals to mx plus b. All right, so you just gotta make sure everything's supposed to be in the form that we most commonly see them in. Meaning for the quadratic, it's in standard form like this, and for the linear, it's in slope-intercept form, okay? Now, let's move on then. How do we solve this? So look at this one, right? For example, right? That is standard form, so change it to this, right? Okay, all right. Now, the other way we could solve is graphically. Remember when we solve systems of equations? Now, these are set up pretty well for us. If you look at the regions questions, they're pretty well set up, meaning like there's really not that much that we have to manipulate, all right, just to get the answer. So for example, for this one, right, if we look at this one, now think about it like this. If you look at this and you have to solve this algebraically, meaning non-graphically, right, using algebra, you look at this and you're like, wow, I'm really like, I don't know what to do here. Well, actually, you probably do, because have you noticed, right? They're both y equal. So remember the good old classic Greek, do I still know how to spell it? The syllogism, right? Meaning if A equals B and B equals C, what can we say about A and C? Right, they're equal, right? Same thing, right? If y is equal to this and y is equal to this, that means these two guys are equal. So meaning x squared plus 5x minus 17 is equal to x minus 5. That's all. All right, now in case you're wondering, well, what am I supposed to do next? Remember, right, if we're solving quadratic equations, eventually, ideally, we could FOIL whatever the solution is. So whatever comes out here, I want to be able to FOIL it or unfoil it, right, and set it equal to 0, right, to get the roots or the zeros, right? So here, meaning we need to pull everything to the other side. We need to get these guys to the other side, all right? So what does that mean? Well, easy. We subtract x from both sides, add 5 on both sides. That's all, okay? Nothing crazy, all right? So that's x squared. 5x minus x is 4x. Negative 17 plus 5 is negative 12, right? And then this is 0 on this side. Now, that should look very familiar to you, right? Because now we can actually unfoil or factor it, right? So that's x on both sides. Now, you tell me, think of two numbers that multiply to negative 12 and add to positive 4. Can you think of two numbers? Yeah, 6 and 4, right? I mean 6 and 2, right? So who's going to get the positive sign and who's going to get the negative sign? Look at the sign in the middle, right? So positive 6, negative 2, right? Now I'm going to solve it against 0, so I'm going to write down my two equations, right? So subtract 6, x equals negative 6, plus 2, right? X equals 2. Now, When they say this, I don't suppose that they mean that they only want the x value. I would suppose that they also want the y value because you want a coordinate, right? Because this is a systems of equations, right? So let's give them that. Now, you can do it a couple of ways. You can just plug this in. I mean, actually, this might be even easier because this linear equation, you could pick either one of which, right? Because this linear equation is so simple. So x minus 5, so negative 6 minus 5 is negative 11. So the first point is negative 6, negative 11. The other point is y equals to 2, right? X equals 2, right? I mean, 2 minus 5, that's negative 3. So we got 2, negative 3. Now, in the very event that you forgot how to do that, you know what you can do? Just graph it. Just graph this, right? So let me show you. You can simply, actually, I'll use the last question as an example, okay? Because I want to save you a little bit of time. So looking at this, right? Just go to table of values. See where the numbers repeat, right? Here, like remember the last question, it was negative 4, negative 5, right? And then you can do the same, just to look for the y value, okay? And then you're good, okay? Just make sure your x value matches. So so in other words, what I'm trying to say is don't write, because you looked at it wrong, don't write negative 6 and then put the negative 3 here. Okay? And don't write like, 2, negative 11, okay? Just make sure you're looking at the right part of the table values, okay? All right, now let's see. Now, with that said, I would very much like you to just try this one. All right, and then when you come back, I think I'll just show you the answer key. And that's it for today, okay? We'll stop, okay? So, all right, press pause right now, and then when you come back, I'll show you the answer key, okay? Press pause right now. Okay, all right, and I'm back. Let's see. Now, when you look at these two lines, I just like it when the quadratic equation is on the left side, because then with this equation, with the linear equation, I can just kind of subtract and pull everything to the left side, okay? Now, happenstance, all right, a very happy happenstance is that we got a difference of 2 squares factoring going on, so it's just x plus 3, x minus 3. I substitute it down here, and then these are my solutions. Okay, so that's it. All right, I'm gonna stop here. Yeah, that's good. That's enough. All right, so thanks for watching. If you want more practice, I got another question down here. All right, that's up to you. And also some questions on Delta Math for practice. Okay, so thanks for watching. Have a good day, and I'll talk to you later. Bye-bye. OMG, that was so good.